So we're going to do this quick tutorial on proving the homogeneity of these equations, right? F is equal to ma, s is equal to ut plus half at squared, up to number 4, right? So this is very simple. The trick when verifying the homogeneity of an equation is to substitute the variables in the equations with their units. For instance, the units of s for displacement is meters. So we're going to if we get to number 2, we are going to substitute s with its unit, which is meters, right? So we're going to start from number 1 up to number 4, and I've said these questions in increasing level of difficulty up to number 4, right? But this is very simple. So let's get into number 1. So I'll just take a blank paper and we'll start proving the homogeneity of all these questions. Now, so we want to prove the homogeneity of these equations. So question 1 is saying that f is equal to ma. Question 2 is saying that displacement, which is s, is equal to ut plus half at squared, right? This is squared. I hope you see that clearly, right? So let's start by question 1. Okay, so what is I told you that the trick in verifying the homogeneity of an equation, you substitute variables with their units. What is the unit for force? The unit for force is newtons, and we know that 1 newton, let's just write that aside, 1 newton is equal to a kg meter per square second. So just keep this in mind, okay? Keep this in mind. Okay, so I want you to keep this in mind. So let's substitute n with this in equation 1, right? So kg meter per square second is equal to, what is the unit for mass? The unit for mass is kg. What is the unit for acceleration? The unit for acceleration is meters per square second, right? When the left side of the equation is the same as the right side of the equation, the equation is now proven to be homogeneous. You're done. Okay, question 1 is done. You now see how simple this is. Okay, so let's move on to question 2, right? So in question 2, I would want you to employ what is called the laws of indices, right? The laws of indices. Let's get into question 2. The question 2 is saying that s is equal to ut plus half at squared, right? And s is for displacement. What is the unit for displacement? The unit for displacement is meters, obviously, meters, right? And so meters is equal to, what is the unit for u, which is the initial velocity. The unit for the initial velocity is meters per second. That's the unit for velocity, right? Then ut, t is for time. What is the unit for time? The unit for time is seconds. So we're going to put a dot and we put s. A dot means multiplication. Obviously, when you're doing physics or mathematics, you already know that a dot means we are multiplying. Plus, okay, when you're verifying the homogeneity of an equation, you have to ignore the coefficients. Okay, this is a coefficient. Why do we ignore a coefficient? We ignore a coefficient because a coefficient has no dimensions, or it has no units. Half has no unit. Okay, of which we are verifying, we are proving the homogeneity of an equation. So we ignore a coefficient because it has no dimension. Okay, so plus half, we ignore half, at squared. Okay, so what is the unit for a acceleration? The unit for acceleration is meters per square second. T squared, it means time squared. What is the unit for time is s. But t is being squared here, which means s squared. Unity for time squared. Okay, so I want you to employ the laws of indices now. So the first law of indices says that, for instance, this is an example. Okay, this is an example. If a to the power 7 times a to the power 1 is equal to what? We add the powers, you know this, right? So the solution will be a 7 plus what? Plus 1. So the solution obviously will be a to the power 8. Done. These are the laws of indices. So we are now carrying on to our question, which is question 1. Okay, so let me write it down again. So which is question 2. So question 2 is saying m is equal to m s to the power negative 1, right? Then I want you to pay keen attention now, very close attention. So we're saying that s to the power negative 1, right? Then times s is just the same as s to the power 1. Right? You know this, right? That a is just equal to a to the power 1, right? It's just the same. right? Then we say plus m to the power negative plus m to the power negative so we're saying plus m s to the power negative 2, right? Meters per square second plus m s to the power negative 2 times s, okay, I forgot to put a dot here, plus s to the power negative 2, to the power 2. Okay, so what does the laws of indices say here? In this case, the laws of indices will obviously say that this is s to the power negative 1 times s to the power 1. Okay, we add the power, so which means s to the power negative 1 plus 1. This will lead to s to the power what? This will lead to s to the power 0. What is s to the power 0? Anything raised to the power 0 is 1. Right? If we say z to the power 0, it's always equal to 1. P to the power 0 is equal to 1 again. Anything raised to the power 0 is 1. Okay, so in this case, we're going to add what? That's calculated. S to the power negative 1 plus s to the power negative 1 plus 1. This will lead to s to the power 0, which means 1. So in this case, m will be equal to m, right? Plus, okay, m will be equal to m s to the power 0 plus, in this case also, m will be equal to, in this case, so m is going to be equal to m s to the power 0 from calculating this part, plus m s negative 2 plus 2 will also lead us to s to the power 0. S to the power 0. Okay. Right? So, okay. I want you to keep in mind, right? So anything raised to the power 0 is 1. So s to the power 0 will be 1. And s to the power 0 will be 1. So our equation now will now translate to be m equal to m plus m. So the left side of the equation is now the same as the right side of the equation, right? So basically, the equation is homogeneous. Okay, so you're done. So let's now move on to question 3 and 4. These are quite interesting because there's this requires tons of simplification, right? So we're going to start with question 2 on a blank answer sheet. On a blank answer sheet, I mean. Okay, so let me just write question 3 on a blank answer sheet, then we'll start proving the homogeneity of equation 3. Okay, so I've written question 3 and question 4 on a separate answer sheet, right? But I want you to take note of something here. I want you to take note of something from the question. So the question is saying that for number 1 and number 4, the question is saying that given for question 3 and question 4, a is a dimensionless constant, right? So I've mentioned this earlier. When something is dimensionless, I mean, when something is dimensionless, it means it has no units. So we ignore it, right? It has no units, so it's going to be ignored in the equation, right? So given that for question 3 and question 4, a is a dimensionless constant and t for period, right? T for period. Okay, so we know that the unit for t for period is what? 1 over s or 1 over t, right? 1 over t, where t is time. That's the unit for period, t. And rho for density. You know that rho stands for density, and L the length, right? So rho for density, the unit for rho is kg cubic meter, right? Kg per cubic meter. And L for the length, the unit for length is what? Is m, right? And the Young modulus E, right? The unit for Young modulus E is kg per meter per square second, right? So let's start proving the homogeneity of these equations, right? So let's start with question 3, right? Question 3. Okay, so we are now verifying the homogeneity of equation 3. So if equation 3 is homogeneous, whatever that is on the right-hand side, these quantities that are on the right-hand side must be the same as the quantity on the left-hand side of the equation, right? If the equation is homogeneous. If that is not the case, it means the equation is not homogeneous. So what is on the left hand side? We have t, which is for period. What is the period? T is equal to 1 over t, right? The period is equal to 1 over time, right? Of which t stands for time. What's the unity for time? The unity for time is s. So therefore, if we simplify it further, t is equal to 1 over s. Then we substitute 1 over s in the equation at the left hand side for t, since t is equal to what? To 1 over s, right? So let's now substitute whatever that is on the right hand side of the equation with their units, right? So keep in mind that the question said that a is a dimensionless constant. When something is dimensionless, it has no units. For the love of God, it has no units, so you ignore it, right? So this is rho, right? So t is equal to a times rho over modulus e root of g L to the power 3, right? L is in meters, the length of the rod. Then g is the gravitational acceleration. So let's prove them. So let's now start substituting each variable with its unit. A has no units, right? So then rho, the units for rho, which is density. Rho is the units for rho is what? Is kgs per cubic meter. Kgs per cubic meter over E. The unit for this is modulus E. The unit for modulus E is kgs per meter per square second. Kgs per meter per square second. That's the units for modulus E, right? Then under the root of what? Under the root of g, the acceleration. The gravitational acceleration is g. What is the unit for acceleration? The unit for acceleration is m meter per square second. Meters per square second. Then what is the unit for L to the power 3? L is length, right? So if we just substitute L with its unit, which is m, length to the power 3, right? What means multiplication. Okay, so we are now here. So if we are correct, if the equation is homogeneous, if we simplify the right hand side of the equation, it must lead to 1 over s. Then the equation would be said to be what? To be homogeneous. So let's simplify the right hand side of the equation. So I'll again want you to employ the laws of indices here. So if you want to give this a try, you can pause the video and try it for yourself. So let's continue. So we can see that we have g under and we have g on top. So kgs on top and kgs under. So these will cancel out each other, obviously. Okay. Then the equation will look like this. 1 over s is now equal to what? 1 over s is now equal to m to the power negative 3. M to the power negative 3 over m to the power negative 1 s to the power negative 2 under the root of m s to the power negative 2 times m to the power 3. Okay. For the moment, don't concentrate. For the moment, ignore what's under the root sign, right? Let's focus on what is outside, right? And at this point, I want you to employ the laws of indices, right? So what does the laws of indices say when you're dividing something? So for instance, when you're, if it's a to the power 2 divided by a to the power 2, right? A to the power 2 divided by a to the power 2 obviously is equal to 1, right? But the laws of indices say what? Is now it will be equal to a to the power 2 minus 2. We subtract the powers. Obviously, if you subtract 2 minus 2 is going to lead to a to the power 0. Anything raised to the power 0 is 1. Therefore, you can see that a to the power 2 divided by a to the power 2 is equal to 1. According to the laws of indices, you subtract the powers, right? So a to the power 2, this power 2 minus this power 2, leading us to a to the power 0. Anything raised to the power 0 is again equal to 1. You see now. So in this case, I want you to take note. In this case, we have m to the power negative 3 and m divided by m to the power negative 1, right? So what are we going to do here? So if we simplify these guys, it will lead it will lead to, this is m to the power negative 3 divided by m to the power negative 1. What do? We subtract the powers, right? Subtract the powers. Therefore, which means this is going to lead to m to the power negative 3 minus 1, right? We are subtracting the powers. M to the power negative 3 minus m to the power negative 1. So we are subtracting negative 3 minus negative 1. So negative 3 minus negative 1, a positive and a negative. A positive and a positive here will lead to a positive. I mean, a negative multiplied by a negative will lead to a positive. Therefore, then m is equal to negative 3 plus 1, like this. Whenever a negative is over a bracket with a negative, or a negative times a negative, bracket means multiplication, that will lead to a positive. So negative 3 plus 1, what's that? Negative 3 plus 1 is equal to negative 2. So this will lead to m to the power negative 2. Right? It will lead to m to the power 2, negative 2. So therefore, in the equation now, keep in mind we are proving the homogeneity of the equation. So 1 over s is now equal to m to the power negative 2 over what? Negative s to the power 2 over s to the power negative 2, right? Under the root of what? M s to the power negative 2 multiplied by m to the power 3. Okay, so you have to play with the laws of indices quite more when you're proving the homogeneity of an equation, right? You have to what? You have to be adamant with working with indices, right? With working with the laws of indices, right? So m is just the same as m to the power 1. So bracket multiplication, what? Dot means what? We are multiplying. And when we are multiplying, we add the powers. Therefore, in the brackets, we are going to see that m to the power negative 2 over s to the power negative 1. We are now concentrating with what is under the square root sign. We have m to the power 1 multiplied by m to the power 3. Therefore, we are going to add the powers, and that will lead us to s to the power negative 2, right? S to the power negative 2 multiplied by m to the power 4. We have added the powers, right? We've added the powers. Okay, so at this point, I want you to pay close attention, because this is where the whole thing becomes tricky, right? So I want you to pay close attention. So, for instance, right, we have just for example, we have a to the power negative 1. A to the power negative 1 is just equal with a 1 over a. So keep this in mind, right? A to the power negative 1 is equal to 1 over a. So in our bracket now, under the root sign, we have under the root sign we have s to the power negative 2. So this is also equal to 1 over s to the power 2. You see it now. So I want you to ingest that. Okay, so let's go further down with the equation. So 1 over s, again, the left hand side of the equation is remaining the same, is equal to m to the power negative 2 over s to the power negative 2 under the root of what? 1 over s to the power 2. To remove a negative, you just put it under 1, right? For instance, I've already told you that s to the power negative 2 is equal to 1 over s to the power 2. 1 over negative 1, a to the power negative 1 is equal to 1 over e. A to the power negative 1, for us to just to simplify it further, is a to the power negative 1 is equal to what? To 1 over a. S to the power negative 2 is equal to 1 over s to the power 2, right? So I've simplified this s to the power negative 2 to this. Then m to the power 4. Right? So I want to write this this whole equation on a separate clean paper, and we'll continue simplifying it further until it leads to 1 over s. If it leads to here, the equation would be proven to be homogeneous, and you're done with physics. Okay, so let me take a blank paper and we'll continue simplifying it. Okay, so we're at this point in the equation. So at this point in the proving the homogeneity of the equation. Okay, so we've traveled from the equation right down onto here. Then I've copied this question on a clean paper so that we can continue working it out because I had run out of space. Okay, so this is the question on a clean answer sheet. Okay, so let's continue solving the question, right? So, all right, the square root. I want you also to keep this in mind, okay? Whatever I write on the right hand side of the paper, keep that thing in mind, okay? So the square root of one, I mean not one square. The square root of 1 is equal to 1, okay? The square root of 1 is always equal to 1, right? 1 times 1 is equal to 1, right? So the square root of 1 is equal to 1. Then also I want you to keep this in mind. The square root of m to the power 4 is equal to m to the power 2, right? You just divide the power by 2, right? So therefore, the square root of what? The square root of m squared is equal to m. This is come on. This is from 2 mathematics, and I hope obviously you know this because you're A level, right? So let's start simplifying now. So for the moment we are concentrating on what is under the root sign. Okay, so what is under the root sign? What is the square root of 1 is 1 over what is the square root of s squared? The square root of s squared is s. What is the square root of m to the power 4? The square root of m to the power 4 is m to the power 2, right? Then we've now gotten rid of the root sign, right? And what? This term, we just bring this term down as it is. We have not simplified that term yet. So m to the power negative 2 over s to the power negative 2. Okay, multiplication. So 1 over s. The left hand side of the equation will remain exactly as it is, right? So we are now here. I hope you're seeing clearly. So now we are now doing some simplification. Right? So see, we have common bases. We have m and m. Those are like terms, right? Right? So negative m to the power negative 2 times m to the power 2. What's that like? Okay, so let me write that down. We have m to the power negative 2 multiplied by m to the power 2. So this will lead to 1. How do I know that? The laws of indices say that when you are multiplying powers with the same base, you add what? You add the powers. So therefore, we're going to see that m to the power negative 2 plus what? Plus 2. We're now adding the powers. Negative 2 plus 2 is equal to 0. So this will lead to m to the power 0. Anything less to the power 0 is 1. Right? So keep that in mind. M to the power negative 2 times m to the power 2 is equal to 1. So these terms, m to the power 2 and m to the power negative 2, will lead to 1. Therefore, we are now going deeper. We are simplifying further. Therefore, s, 1 over s, the period 1 over s is equal to what? Is equal to 1 over s to the power negative 2 multiplied by 1 over s. Okay. To those of you who are wise enough, this is a done deal. Okay, so dot means multiplication. I've said this again and again. So the reason why I keep repeating things is that I don't want people to be confused, right? I want people to stay on board, right? So this is the point we are at. So I want you to keep in mind now. Okay, I've told you before that I've mentioned this before that s to the power negative 2 is equal to 1 over s to the power 2, right? So we have s to the power negative 2 in the denominator. So 1 over s is now equal to 1 over x to the power negative 2 times 1 over s. You see that? So 1 over s to the power negative s to the power 2. So s to the power negative 2 is just the same as s to the power negative 2 is just the same as 1 over s to the power 2, right? This is the same as this, right? I've said this when I was explaining it here, that s to the power negative 2 is equal to 1 over s to the power 2, right? So if we simplify 1 over s to the power 2, this will lead to 1 over s will lead to s squared multiplied by 1 over s, right? This is simple division, right? S will cancel out s, leaving us with 1 over s equal to s. S and 1 is equal to s. Therefore, the equation is not homogeneous. The equation is what? It's not homogeneous, obviously, because 1 over s is not the same as s. Therefore, the equation is not homogeneous. Then you're done. Let's now get to question 4, right? Question 4. Let's get into question 4. Question 4 is saying that t is equal to al root of rho over e, right? I've told you that the units of e modulus e is equal to kgs per meter per square second. Those are the units of e, right? So if you want to give this a try, go ahead and give it a try. Okay, so I'll work it out, then you see whether you're correct. So let's get deeper into this. Okay, so much of the explaining that is needed to solve question 4, I've already explained all those stuff in question 3. So question 4, I'm just going to solve it as quickly as possible, right? So t is what? T is 1 over s equal to what? A is dimensionless constant. You ignore it, right? So a, we're going to ignore a because it has no units. Then L stands for length. The units for length is what? Is meters. Under the square root of what? The square root of rho, which is the density. What is the unit for density? Which is kg meters per cubic meter. Kg per cubic meter. That's the unity for density. Over, what is the unity for modulus E? I've told you the unit for modulus E is kg per meter per square second, right? So then you put kg per meter per square second. That's the trick. That's what you do when you're proving the homogeneity of an equation. You'll be just substituting the units of the equation with their variables, right? So 1 over s is equal to this. So let's simplify what is under the root sign, right? So kg will cancel out kg, right? Leaving us with we now have meters to the power 3 over m to the power 3, which is meters to the power 3, over meters to the power negative 1, which is m to the power negative 1, right? So let's simplify that. You just employ the laws of indices, right? So if m to the power 3 divided by m to the power negative 1, what do? We add the powers, right? So we're going to add 3 plus negative 3. No, when you're dividing, you subtract the powers. So this is equal to, we have the same base here, which is m. So this is equal to m to the power 3 minus 1. Okay, so because we are subtracting the powers, whenever you're dividing number bases with the same base, right? Variables with the same base. This is m to the power 3 and this is m to the power negative 1. They have the same base. You when you're dividing, you subtract the powers. When you're adding, you add. When you're multiplying, you add the powers, right? So let's just simplify here. If we simplify here, it will lead to what? M to the power 4. So this is m to lead to m to the power 4. How did I get m to the power 4? Okay, negative multiplied by negative lead to a positive. Therefore, will be 3 plus what? Plus 1, which is m to the power 4. Right? So in the bracket now, not in the bracket, under the root sign now, we now have 1 over s is equal to m outside the root sign. Under the root sign, we now have m to the power 4 over what? Over s to the power negative 1. S to the power negative 2, I'm sorry. S to the power negative 2. right now. So we need further simplification. Don't mind this. This is side working. Okay. Don't mind these workings that are on the side of the paper. This is just side working when I'm explaining stuff to you. Okay. So we now have 1 over s is equal to m under the root of m to the power 4 over what? S to the power negative 2. And I've told you that s to the power negative 2 is just equal is 1 over 1 over s to the power negative 2. 1 over s to the power 2. This is equal. S to the power negative 2, there is a negative here, if you're not seeing it clearly. So s to the power negative 2 is equal to 1 over s to the power 2 without a negative. Here, there's no, the s is without a negative here. So s to the power negative 2 is equal to 1 over s to the power 2, right? So that's as simple as it is. So 1 over s now equal to m, this m under the root of what? We're now simplifying what is under the root sign, right? M to the power 4, right? Over 1 over s to the power 2. Right? So if you do your math accurately, right? So in other terms, this is saying that m to the power 4, right? Divided by what? Divided by 1 over s to the power 2. Right? M to the power 4 over 1 over s to the power 2. M to the power 4 over 1 over s to the power 2 is that the same as 4 m to the power 4 divided by 1 over s to the power 2. Okay. This is now mathematics. I hope you're getting it. Then obviously if you simplify this will lead to what? M is just the same as what? M over 1. If you simplify it, m to the power 4 over 1, the division sign will change to a multiplication sign, and this will somersault. Right? If it somersaults, the bottom becomes the top, which means s to the power 2, the numerator, the denominator will become the numerator. S to the power 2 over what? Over 1. To somersault. Right? Then obviously we are now seeing that we are now ending with m to the power 4 times s to the power 2. So simplifying this, that is under the root sign, will lead to m to the power 4 times m to the power times s to the power 2. Right? So 1 over s is equal to m under the square root sign. What do we get if we multiply m to the power 4 over 1 times s to the power 2 over 1? Come on, the over 1, we ignore this. Anything divided by 1 will just remain the same. So m to the power 4 times s to the power 2 will lead to m to the power 4 s to the power 2. M to the power 4 s to the power 2. Right? Are we here? Everyone is here. So what is the root of m to the power 4? The root of 1 over s is equal to, the root of m to the power 4 is m to the, this m that is outside the root sign will remain the same. Then the root of m to the power 4 is m to the power 2. The root of s squared is s. Right? So if we multiply m and m, will lead to 1 over s will lead us to what? To m. M and m will lead to s to m to the power 1. This is just same as m to the power 1 times m to the power 2. This will just lead to m to the power 3 times s. This is not homogeneous. It's not homogeneous at all. Okay? Then you're done.